Let's talk about colors. Why do we see different colors? Does everyone see colors the same way? Why does the sun sometimes look yellow, orange, or even red? In this video, we'll answer these questions and dive into the amazing science behind the colors all around us. We all know we see the world through our eyes. But what does that really mean? How do our eyes take in the color of an object like a red apple or a blue sky? To understand this, we need to talk about light. Light travels in waves, and these waves carry energy. Although we can't see the waves themselves, the way they interact with our eyes is what gives us the experience of color. Let's start with the most familiar light source, the sun. Sunlight and waves. Sunlight might look white to us, but in reality, it's a combination of many different wavelengths of light. Each wavelength corresponds to a different color. Shorter wavelengths, around 450 nanometers, appear blue to us. Medium wavelengths, around 570 nanometers, appear yellow. Longer wavelengths, around 700 nanometers, appear red. If you combine all these wavelengths together, like sunlight does in space, we perceive it as white light. So when sunlight hits our eyes directly, we see bright, white light. But when it reflects off surfaces, we start to perceive different colors based on which wavelengths are absorbed and which are reflected. Let's bring it back to something simple. Say you're looking at a red hat. Is it creating red light? Not exactly. The red hat isn't producing red light. It's reflecting the red wavelengths from the sunlight and absorbing all the others. That's why it appears red to us. The colors that are absorbed don't just disappear, they're transformed into heat. That's why dark-colored objects, like a black t-shirt or a black car, get hotter in the sun. They absorb more light and more energy, which becomes heat. Meanwhile, a white object reflects almost all the wavelengths and stays cooler. The visible spectrum and beyond, our eyes can only detect a small portion of all the electromagnetic waves out there. This range is called the visible spectrum, and it includes all the colors from violet to red. But beyond red lies infrared, with waves that are too long for us to see. And beyond violet is ultraviolet, waves that are too short. Even though we can't see these wavelengths, they still exist, and they can have powerful effects. Do animals see color like us? Not at all. Different animals perceive color in totally different ways. For example, dogs see a limited range of colors. They mostly see shades of blue and yellow. But reds and greens? Not so much. Bees can see ultraviolet light, which is invisible to us. This helps them detect patterns on flowers that guide them to nectar. And some creatures, like the mantis shrimp, have dozens of color receptors. They can see colors we can't even imagine. So when you wonder, do others see color the same way I do? The answer is a big no, especially across species. Mixing colors, light versus paint. Here's something that might seem confusing at first. When you mix all colors of light, you get white. But when you mix all colors of paint, you get black. So what's going on? It comes down to two types of color mixing. Additive color mixing. This happens with light. If you shine red, green, and blue light together in the right intensities, your eyes perceive white. That's how screens work. TVs, phones, and computer monitors all use additive mixing to create every color you see on screen. Subtractive color mixing. This happens with pigments, like paints and inks. When you mix colors, each pigment absorbs or subtracts certain wavelengths. The more pigments you add, the less light is reflected, and the result gets darker and duller. Mix enough colors and you get black, which reflects almost no light. Why the sun changes color? Refraction and scattering. Have you ever noticed how the sun looks yellow during the day, turns orange as it sets, and sometimes even appears deep red near the horizon? This isn't because the sun itself is changing color. It's because of how sunlight travels through Earth's atmosphere. Refraction and scattering. When sunlight enters the atmosphere, it gets scattered and refracted by air molecules, dust, and particles. Scattering affects shorter wavelengths like blue and violet more than longer ones. This is why the sky is blue. Blue light is scattered in all directions. But as the sun gets lower in the sky, like during sunrise or sunset, sunlight has to pass through more atmosphere. That longer path scatters away even more blue and green light. What remains? The longer wavelengths, yellow, orange, and red. That's why sunsets and sunrises glow with those warm colors. Refraction bends the light. There's also a phenomenon called refraction. This happens when light bends as it moves between materials with different densities, like space in our atmosphere. At sunset, this bending causes the sun to appear slightly higher than it actually is, and also stretches and distorts the colors we see. This effect amplifies the warm tones. So, next time you see a golden sunset or a fiery red sun, remember, it's the result of physics happening in the air around you. Summary: how we see color. Light waves carry different colors based on their wavelength. Objects reflect certain wavelengths and absorb others. Our eyes detect those reflected waves, and our brain turns them into the experience of color. Other animals see very different colors, or even completely different parts of the spectrum. And finally, mixing light is not the same as mixing paint. One adds color, the other subtracts it. If this video added some color to your day, make sure to like, subscribe, and keep the spectrum going.